Hi, good morning. We are going to continue with decimals today. And we're going to continue on to section 2.5. And when we start off our paper, we're going to put our normal stuff on the top. I'm going to make sure that my name is up there. Our date, it is 9/28. And we are doing notes on 2.15. And this one, we're going to be kind of re-looking at previous ways to solve algebra equations, but this time we're going to be using division to do so. And I'm going to explain what that means. So our title is going to be Division to Solve Decimal Equations. I tried getting the sound to sync up a little better. I hope that you notice, or well, if you don't notice, maybe you don't care. But it was something that I wanted to do, so should be good. Sorry about the extra noise in the room. It's probably there's a big buzz. It's just because I have like 10 fans going right now because it's pretty warm and hot today. All right, so the big question that we're going to be asking ourselves today is how do we solve an equation when it looks like this? Say I have my equation and it's 3.7x equals 7.77. Now, previous to today, what we would do is we'd ask ourselves 3.7 times what is 7.77? And that usually works fine when it's something like 2x equals 10, and we can be like, what times 2 is 10? We know that's 5 because we kind of have a good feeling for our facts. But when we start adding in decimals in here, I can't really ask myself this question because it might take me an hour to guess and test this. And I don't have an hour, and I'm lazy. And there's way better ways to do this. Now, some of you that have gone ahead and gone, you probably already know how to do this, and that's okay. I'm only going to have you write one example or so, and then you're going to just go to your homework. But for those of you that aren't, I want you to pay attention and do some writing with me. All right, so the question is, how do we solve that? And the trick that we're going to be using today is called the inverse property of multiplication. Now, before I go into more detail about this particular one, I want to refresh our memories about some of the other inverse operations that we learned, especially the inverse operation of addition. So remember, that allowed me to solve problems like x plus 4 equals 12. Now, I could use guess and test for this, but pretend like I don't know my facts for a moment. I could say, oh, I need to get x by itself on this side of the equation. So I need to turn 4 into something that will disappear using my mathematics magic. And if I turn plus 4 into a plus 0, that will simplify down into an x, and I've just got x by itself. So then I can say, oh, plus 4, what do I need to get to that to be a 0? I can just subtract 4. So I can write x plus 4 minus 4. And remember, if I do that on this side, if I subtract 4, I have to do the same thing on the other side. So I would write 12 minus 4. Simplifying x plus 4 minus 4, I can just write x equals 12 minus 4 is 8. Nice. So I can solve it using the inverse property of addition. But if I turn it into a 0 for multiplication, it's not going to work, because if I multiply by 0, I just get 0, and then I end up with 0 equals 0, so it's not useful, right? So I'm going to have to do something else. Instead, in multiplication, if I'm multiplying something to make it stay itself, so if I was going to multiply 4 times something to make it stay a 4, instead of a 0, I can't use a 0 because it'll turn it into 0, I'm going to use a 4 times 1. Which kind of gets it back to itself, right? So I need to turn the 4 into a 1, because the 1 is kind of our key here. So our inverse property of multiplication looks like this. It says the product of any non-zero number and its reciprocal is 1. The product of any non-zero number and its reciprocal, I'm going to make sure I spell this one right, recip is 1. Great. I don't know what a reciprocal is. Alright, a reciprocal is this. Reciprocal. If you recall, you might have talked about this in fractions before. If not, that's okay. That's when we take a number and we take its numerator and denominator and we just flip them over. So if I was going to write 1/2 and I was going to take the reciprocal, I would write 2/1, which I can simplify as 2. Okay, let's go down a little bit because I made a little bit of a mess of this page. Great. How does that help us? Well, before we go on, I forgot to do this part. We're going to write our general rule of what the inverse property of multiplication looks like. And that is this. If I take a times 1/a, it equals 1. Let's take a look what that means. If I say that 4 times 1/4, what does that equal? Well, if I'm multiplying my fractions out, I can see that 4 would go on the top. 4 times 1 is 4. And this is 4/1 because it's 4 wholes. 4 times 1 is 4. 4/4 is 1, which simplifies down to 1. So any number times itself, times its own reciprocal like that, turns into a 1. Okay, how does that help us? Let's look back at that initial problem that we were looking at. 3.7x equals 7.77. Now, my goal here is to not use guess and tests. So I need to get rid of this 3.7. So my key here is that if I turn this 3.7 into a 1, it will mean that x times 1 can simplify down to an x. And my goal is always to get x by itself. Alright, so what is the reciprocal of 3.7? Well, all I need to do to take the reciprocal is just flip my numerator and denominator. So if 3.7 is the number, and I'm going to take the reciprocal of it, it's just going to be 1/3.7, which is kind of like dividing by 3.7. So what I'm going to do is I'm going to divide this whole side by 3.7. Now if I divide this side by 3.7, you know what I'm going to have to do. I'm going to have to divide this side by 3.7 as well. Exactly. So now I can write, I'm going to just take a look at this side for just a moment, so I might get a couple of steps ahead. 3.7 divided by 3.7. Well, if I go and pull up my calculator, I can do that if I want, but I know that's going to be 1, because anything divided by itself is 1. So I can write 1 times x. And I just simplified that whole thing. Wait, don't I have to divide 3.7 by x here as well? Well, no, because my associative and commutative properties of multiplication that we were just talking about tell me that I can change around any division and multiplication that I want as long as they are all being multiplied together, which is kind of nice and it's really handy here. I could say 3.7 times x divided by 3.7, but that wouldn't get me any more simplified than I am now. So instead I'm going to just take this part, divide it together, and turn it into a 1. Now I know that 1 times x is 1, because 1 times any number is the number. So now I have x by itself. Awesome. Done. Now I have to go back and simplify my other side. Now you can use the long form of long division if you'd like, but I'm going to use my calculator because my focus now is the algebra, not necessarily the long division. So I'm just going to take 7.77 divided by 3.7, and that's going to give me 2.1. Alright, now I can do a quick little test to see if this works out. I can plug it back in the beginning and I can say this 3.7, oops, am I blocking? 3.7 times 2.1, does that equal 7.77? Let's check. 7. 1 times 3 is 3, 6. Oh, sorry, it's 3, obviously. Put a 0 down here, cross out my 1. 2 times 7 is 14. 2 times 3 is 6. 7, if I add it up, 7, 7, 7, 1, 2 decimal point. It's correct. So I got my answer, and I did it by dividing whatever number was on this side, and I had to do it both ways. Okay, if you feel comfortable with this, go ahead and go on. If not, I'm going to do 2 more examples, and you can check out those examples in just a moment. We'll call this one example 1. Okay, let's go look at 2 more. If you're sticking around with me, if you are, I appreciate it. Thank you very much. All right, let's solve a couple more equations using our inverse property of multiplication. Example 2. We're going to take a look at this one. It goes like this. 4.5x equals 12.6. All right. So, darn it, my x is not by itself again. So I need to get this x all by its lonesome over here. And to do that, I need to get rid of this 4.5. So what I'm going to do is I'm going to take the reciprocal of 4.5. So if I take my 4.5 and I take the reciprocal, remember, that's going to be 1 over 4.5. So I can just divide it, because this is really like dividing by 4.5, right? So I'm going to take this whole side and I'm going to divide it by 4.5. And if I do that to this side, I again have to take this side and divide by 4.5. Okay? Got with me so far? 4.5 divided by 4.5 is 1. So I have 1 times x equals 12.6 divided by 4.5. I'm going to use my little calculator for this. 12.6 divided by 4.5. Looks like I have 2.8. Now I'm going to simplify it one more step. Leave my x all by itself. I have x equals 2.8. Nice. Easy. I just have to remember that I'm dividing by whatever is on the side with the x, and that's the one that I'm getting it alone. Okay, let's do one more quick example. Example 3. Let's see, I'm going to have 4.7, a lot of 4's in these 2 examples, x equals 10.81. Now, remember that we do have an implied multiplication here. So I'm going to, again, I know I'm going to be dividing by something, and I'm going to be getting the reciprocal of 4.7, which just means I'm going to divide this side by 4.7. Nice. 4.7 divided by 4.7 is 1 times x equals 10.81. Oh, I forgot to divide. It has to be 4.7 though, because that's what it was on the other side of my little equation. 10.81 divided by 4.7. And that equals 2.3. Nice. Oh, I've got to simplify, of course. X equals 2.3. I want to do one more quick one. Sorry, this is not example 3. This is example 4. And this one just might be a tiny bit different. I'm going to be doing 57.72. Oh, sorry, it's supposed to be 54.72. 54.72 equals 5.7x. x. Oh, okay, so one immediate thing that I might notice here is that on this side I have my x instead of on this side. Is that a problem? No, definitely not. It can be. I can really flip it if I want because it doesn't really matter what order it's in. But over here I'm just going to divide by whatever I have by my x. So I'm going to do 5.7 divided by 5.7. I have to do the same thing over here, 5.7. This way I get x all by itself because 5.7 divided by 5.7 is 1. 1 times x is x. But over here, I'm going to have to do my little calculation. And I have 54.72 divided by 5.7. And that's going to give me 9.6. Nice. I've got my answer. Oops, I forgot to box this one up here. And that's pretty much how it goes. Not particularly difficult, but you just have to remember how this works and why we are doing it. This is going to become more and more important the more that you learn in math and the farther that you go. Is really just going to be manipulating these little equations and applying all of the magical little rules that you're going to learn. All right, let's start on the homework. Good luck.